Hello guys, welcome back to the Civil Engineering YouTube channel. Please subscribe our channel for daily civil engineering videos. In today's lecture, we are going to analyze this simply supported beam, and we have to find out their support reactions and then to draw the shear force and bending moment diagram in a very simple and easy way. So let's consider this is a simply supported beam with the given dimension, and there is a two concentrated load acting on the simply supported beam, one with the magnitude of 2 kN and other with the load of 3 kN. So the one load is acting at a 2 meter distance from this hinge support, and other load at the center of the beam, which is a distance of 4 meter from this hinge support. So we are going to find out first of all their support reaction. So let's consider this is support A and this is support B. So they can resist the vertical reaction RA and it will be RB. So there is no horizontal load, so we don't need to consider any horizontal reaction for this hinge support. So we have to find this RA and RB. So to find out this RA and RB, we can use the equilibrium equations. The first equilibrium equation is summation of moment at any point equal to 0. Either we can use this equilibrium equation or this equilibrium equation or this equilibrium equation in order to find the unknown support reactions. But hence, this is summation of horizontal force is equal to 0, this is summation of vertical force is equal to 0, and this is summation of moment at any point equal to 0. Now we cannot use this equation because there is no horizontal force acting on this beam. So we cannot use this equation. Also, there are two unknown, so we cannot use this equation because this equation is valid when we have to find only one unknown. Here we have two unknown, RA and RB, that's why we cannot use this equation. So the only equation to use is this summation of moment that at any point equal to 0. We can use this equation in order to find these two unknowns. So let's consider the summation of moment at point B equal to 0. Now, and let's consider that the clockwise moment is taken as positive and the anti-clockwise moment is taken as negative. So now RA is acting in upward direction, and this will create the moment in a clockwise direction about point B. So in a clockwise direction, so it is taken as positive. So it will be RA multiplying it with the moment arm, because moment is equal to the force into moment arm. So force is RA, the moment arm is the perpendicular distance from the load up to the point where we want to find the moment. So moment arm is the distance from A point up to B, which is 8 meter. Now this 2 kN load also will create the moment about point B, and it creates the moment in the anti-clockwise direction about point B. So it will be taken as negative minus 2 multiplied with the moment arm. The moment arm is this distance from this point 2 kN up to point B, which is 2 plus 4, which is 6 meter. This 3 kN will also create the moment about point B, and it will also create the moment in anti-clockwise direction. So also take is negative multiplying with the moment arm. The moment arm is this distance from 3 kN up to point B, which is 4 meter. So summation of all the moment about point B equal to 0. Now when we add these, when we multiply these and shift into the right side, so we got 8RA equal to 12 plus 12, or we can say 24. So RA comes out to be 24 divided by 8. So we get RA equal to 3 kN. So this is the support reaction here at this point, which is 3 kN. Now the total load acting on the beam is 2 plus 3, 5 kN, and the reaction, one reaction we found out is 3 kN. So of course, we can know that this reaction will be 2 kN, because in order to take this upcoming load, so this provides 3 kN. So of course, this will be 2 kN in order to support the upcoming load. So 3, this is 2 plus 3, 5. And the upcoming load is also 5. So now this is in equilibrium. So this is 2 kN reaction. Or we can find this reaction by this method, that summation of all the vertical forces equal to 0. And let's suppose this 2 is unknown to us. And upward force is taken as positive and the downward force is taken as negative. Now the upward forces are RA and RB, while the downward force is minus 2 and minus 3. They are taken as negative. Summation of all the vertical forces equal to 0. Now RA is 3 kN, we know that, so it will be RB if we shift this value into the right side, so it will be 2 plus 3 minus RA. So it will be 2 plus 3 minus 3. RA is 3 kilonewton. So by adding these, RB comes out to be 2 kilonewton. So it is 2 kilonewton. Or simply, just by looking into the load and to the reaction, we can clearly say that this will be 2 kilonewton in order to take the upcoming load. Now, this is the first step to find out the support reactions. Now we can draw the shear force and bending moment diagram. So it's very easy and simple way. Just draw the reference line first and then draw the horizontal reference lines. This is for the shear force diagram in the unit of kilonewton, and then we have to draw for the bending moment diagram in the unit of kilonewton meter. So these are the reference line. This will be 0, 0 reference line, and we will start the shear force diagram from this end, from this left end. So the first reaction which is acting in the upward direction is RA, which is 3 kilonewton. So we will start from this point, and 3 kilonewton is acting upward. So we will bring this in the direction of the upward, and it will be 3 kilonewton. Now the upward is taken as positive. It should be kept in mind. So now it is 3 plus 3 kilonewton. Then there is no load on the beam, so it will be a straight line. Then there is a downward load of 2 kilonewton. So this was plus 3, and this is downward, so it is minus 2. So we got plus 1. So it means we will bring this in the downward direction and the plus 1 up to plus 1. So this is now plus 1 kilonewton is the shear force at this point. Now there is no load again in the beam, so it will be a straight line, and there is again downward load of 3 kilonewton. So it was plus 1. Now it is minus 3, it is downward, so we got minus 2. So I will bring this up to minus 2. Now there is no load acting on the beam, so it will be a straight line, and then there is a load of 2 kilonewton acting in the upward, so it will be again in the upward direction, so minus 2 and plus 2, it will become 0. So this is the shear force diagram for this simply supported beam. Now to draw the bending moment diagram, we will take help from these shear boxes. This is plus shear box, this is plus shear box, and this is minus shear box, because this is acting below the reference line, so it is taken as minus, while these are acting above the reference line, so they are taken as positive. Now we will find the area of these shear boxes to find out the bending moment. So now to find out the area of this shear box, so let's suppose this is A1. So this is a rectangle. So the area will be here, area will be A1. It is equal to the rectangle, so it is base into height. Now the height is plus 3 and base is 2 meter. This distance is 2 meter. This distance is also 2 meter, while this distance is 4 meter. So this is a rectangle with a height of 3 and base of 2. So we will just find out the area of this rectangle. So 3 into 2, we got 6. So we will find the moment will be 6 at this point. 6 kilonewton meter is the bending moment value at this point. Now we will find the area of this box. So A2, this is also a rectangle with a base of 2 and a height of 1 meter. This is 1 kilonewton is the height and 2 meter is the base. So it 1 into 2 equal to 2. So we will add these two values because this is acting in the positive direction. This is also in the positive direction. So we will add these two. 2 plus 6 equal to 8. So it will be 8 at this point. 8 kilonewton meter is the bending moment at this point. Now the area of this box, which is acting in the downward direction, so it will be A3, and area is base into height. So height is minus 2 and base is 4 meter. So minus 2 into 4, we got minus 8. Now this was plus 8, and now we got minus 8, so we got 0. So it means this negative brings the bending moment value to 0 at this point. So this is the bending moment diagram for this beam. And it should be kept in mind that these were horizontal lines of 0 degree. This was also 0 degree or horizontal line, and this was also 0 degree line. So the bending moment will be 1 degree line or the linear line. They are linear line because the bending moment diagram should always be greater, 1 degree greater than the shear force. If shear force was a linear line, then the bending moment will be a parabolic line or 2 degree line. Hope you guys understand, and don't forget to subscribe our channel for daily civil engineering videos. Thank you for watching our video.